Hi everybody, I'm Kristen. I'm a polymer chemist at IBM Research and I will tell you everything about Clue today. So before we start our experiments, I want to tell you a little bit what Clue is and how Clue works and the different kind of clues there are. So most of you probably know like the school Clue, the regular Clue. There's also a hot Clue, the hot Clue gun, and the other big type of Clue is like the instant Clue, also the epoxy Clue. So Clue is usually made out of a polymer, and a polymer is a long chain of molecules, and they almost look like spaghetti. Like you take like your cooked spaghettis, and this is like polymer, how polymers usually look like. And if you look into a bowl of spaghetti, you can see that they're all kind of like entangled to each other, and that's why they hold together. So it's really hard to get one out of it, and you usually get like more than one with it. So that's how Clue works, and usually it's solid Clue. That's why it sticks together. So you have different ways to make it liquid, so you can apply it to your surface. So one is you dissolve it in a solvent. That's usually the Clue you can buy for the school Clue or just the regular household paper Clue. So there's some solvent in it, and what it does, it basically dries off the solvent, and then it hardens, and then you glue things together. The other way you can do it, you can make it hot. So your plastic, which is basically the things you put in your hot glue gun, your plastic melts, so you can apply it to your surface, and then it cools down and basically hardens when it cools down. And the third one is you basically have a polymer which is liquid, and then because you add another substance to it, it cross-links and it forms Clue. So this is basically the super glue, and the super glue forms a cross-linked polymer with the water in the air or the water in your breath. So if you breathe a little bit on the super glue, it actually works faster than if you wouldn't. And with the epoxy, you have the two components which you have to mix together, and then they need like 5 minutes or so to get set, and then you form the glue. So let's see what was in our bag and what else we need. So in the bag you should have safety goggles. You have a little plastic bowl. You have a little spoon and a pipette. You have some popsicle sticks. You have a little cheesecloth bag, string, then a little bottle which says vinegar on it. You have your milk. You have some liquid glue. Then you have this little bag which says sodium bicarbonate on it. You have a cup. And you have a bag of little pebbles. You all need that for the first experiment, and then for the second experiment you have this like purple glue stick, the post-its, a little bag with sand, and also that like really smooth white paper. So what else you need? You need some little pieces of paper, which you can cut out from any like old paper you find. And you need one just empty cup and a little bit of water and a pen. So the first experiment we are going to make is glue out of milk. And that's actually the way they made glue years ago, before they could make like synthetic plastics. And that's why they have these little cows on the Elmer's glue. Because they actually like 80 years ago they made it out of cow milk. So the instructions for this will be in the little journal you got on page number 4. And we need all the safety goggles, and let's get started. So we're going to take our milk and pour about half of the milk into the little cup we have. And then we take this to the microwave and heat it up for 30 seconds. If you need help from your parents, please call your parents to help you with this. after you warmed up the milk, you take your little bottle of vinegar and the pipette and your spoon. So you can put the spoon in the milk, and then you add about 4. So to use the pipette, you press down the thick part, put it in the vinegar and let go, and then it fills up. So you put this into the milk and then stir with your spoon, and then add 3 more pipettes of vinegar. So we will wait for like 2 minutes until the white stuff falls to the bottom and it's easier to filtrate it off the liquid part. And during the time we're waiting, I will show you what actually is happening. So in the milk, there's a lot of water, there's a little bit of fat, there's a little bit of sugar in it, and there's also protein in it. And there's a protein in it which is called casein, which is actually a really long chain of protein. In the form it is in the milk, it is folded up like this. So it has like parts of the chain are like in these like zigzag, parts of the chain are in these like helix structure. So it's really nicely ordered, and they don't do this like spaghetti forming that they kind of like all intermix with each other. What happens if you add the vinegar to it, it actually starts to lose the form it has, so it folds up and starts to form this like spaghetti structure and can form into like a coil. So after about 2 minutes, your milk should look like that. So it's kind of like yellowish at the surface, and well, you don't see the white stuff down there, but the white stuff is down there at the bottom. So now we're gonna use our cheesecloth and slowly pour your milk into it to basically get separate the liquid from the solid part. And you can use any like empty cup you have to catch that liquid coming out of it. So you can slowly pour in the first very liquid part, so it's easier to filtrate that one, and just press a little so it comes out here. And once you have most of the liquid out, then you can add the last part of it, which contains all the white little clumps. And then use your spoon to basically get the rest out of it. And again, you can just press the liquid part out of it. You might want to do this on a table where you either put some protective surface on it, or you can easily wash it later. So if there's no liquid coming out anymore, you can open it up, and all that white stuff in there, you're going to put it back into your plastic cup, and you can use the spoon to just scrape it off. worries if you don't get everything off. We should have more than enough to make our clue. So now you have these little crumbs in there. Now we're going to add a little bit of water to make it into a liquid, like you expect from a clue. So add a little bit of water at the time and stir it. Until you feel it has like a clue-like consistency. So you don't want it to have it too liquid, but you want to have it into like at least that it kind of like drops down. And now, since it's still very acidic from the vinegar, we're going to add a little bit of the sodium bicarbonate. To basically neutralize the acid from the vinegar. So this is the same you have in baking soda at home. So add a little bit of it to your glue and then stir it. And it gets a little foamy because they're like carbon dioxide forming. So you might want to add some more water to it. So you should end up with something looking like that, which is not too liquid again, but you can at least smear down as a glue. So now we made our glue. You can keep it for a day or so in the freezer before you use it, but at some point it will just basically start to degrade and smell. So now we take our popsicle sticks. You should have 4 popsicle sticks and 2 of them should have holes in it. So we take each one with a hole and one without a hole and then glue these together with like about an inch of overlap. And for one of the sticks you're using your homemade glue, for the other stick you're using your liquid glue. Let's stick the sticks together. So and you have to label them, so because you have to wait for like 6 hours until they're dry before you can test them. So you know which one was what. I will label mine with an M for milk and the other one with a G for glue. And then, as I said, about 1 inch of overlap, so you put like 1 inch your homemade glue on it and then press the other popsicle on it and hold it for a few seconds. Just put it on the side somewhere so it can dry. Use the other stick, you label it with a G. Use your liquid glue you had in the back. You probably have to open it for the first time, so there's a little, if you remove the little cap, there's a little second cap on it which you have to remove first. And then screw on the other cap again, and now it's ready to use. So again, about 1 inch. And also hold it. And then you're done with this. And then you have to keep it somewhere for like about 6 hours, and then you can do the test which glue works better. So the next experiment we are going to do is to test how strong our glue is after we let it dry for like 6 hours. So for this one we need the cup you had and the strings and your 2 test examples and then the pebbles you got. And you might need some some bigger and heavier stones or rocks or whatever you can find on the street. Let's get started. So you take your string. You might have to shorten it a little bit. You don't want to have it too long. Go through the holes in your cup. And take your first past example. I'm using the one with the milk first. And go through the hole there. And then just knot it together. So that the whole thing would look like that. You have your test sample here, the string, and then you have the cup here. So now what we are going to do, you hold it on the upper popsicle, and we will add more and more weight to the cup and see when the glue is failing and basically the second popsicle will slide down. So now we're going to test how much our milk glue is holding up. So as I said, we take the upper popsicle in one hand and then add our pebbles into the cup with the other hand. And basically see when it falls down. As you see, mine is still holding up. So what I'm doing, I'm putting the pebbles back and then add a stone to the cup. And then add some more weight by the pebbles again. So since this is still holding up, I'm just going to add more stones. So since my cup is full of stones already, I got some sand and we'll add some sand to it. This is still holding. So let's see how strong our glue was. So I'm going to put it on a balance just to see how much weight it could hold. And this is about 3 pounds and 9 ounces. So almost 4 pounds of weight. That's a pretty good clue. Our last experiment will be that we test how many times we can stick post-its on different surfaces. So this experiment is described on page number 9. And for that one we need the post-its. We will make our own post-its, so we need just like cut out paper pieces, the purple glue stick. And we want to do different surfaces, so I have a smooth surface here. We have a little bit of sand to make a sand surface. We need a little bit of water to make a wet surface. And for a rough surface, I used a little rainbow here. So let's get started with this experiment. So you're taking one of your post-its, and let's start with the smooth surface. So you apply it to the surface, take it off. This is one time. And do it again. Still sticking. Second time. Still sticking. Third time. And you basically count how many times you can do this until it doesn't stick anymore. So for the post-it on the smooth surface, I tried 100 times and it's still sticking. So that works pretty well. I'm stuck trying this now. It's kind of almost falling apart. So the next surface we will try with the next post-it will be a little sand. So take a little sand bag and then add some sand to your surface. And let's try again with a new post-it. And what do we see? It doesn't even hold the first time. So you can notice down on in the booklet we have. So sandy, it didn't work at all. Smooth, more than 100. Let's try with a wet surface. So we take our pipette and a little bit of the water and wet the surface a little bit. Try a new post-it. And kind of holds. Let's try a second time. The second time it actually works better because it's dried off a little bit already. So right now it's only holding because it's wet. It's like holding like a wet piece of paper on something else that it's wet, but it's not sticky anymore. So that was about 4 times. Let's try a rough surface. So take a new post-it. One time. 2 times. 3 times. So even on rough surfaces, and after like 100 times, it is still sticking. So the next text is on skin. Take a new post-it, add it to your skin. $37. And the last test we're doing is on our t-shirts. One time, two. So even after 100 tries, it is still holding on textile. So the last test we're going to do, we make our own post-its by a piece of paper and the purple glue stick. So just apply a little bit of the purple glue to your piece of paper and then do the same experiment again. We start on a smooth surface. $33. So after 33 it fell off. And I don't know if you realized that once you pressed it down after like the 5th time or so, it got really hard to get off. That was the time when the glue started trying and basically really stick together like glue does. Next one we are going to try is our sandy surface with our own post-its. So take another piece of paper and apply on the purple glue stick. And same as with the post-it, it doesn't even hold once. So now we're going to test our own made post-it on a wet surface. Making the post-it, putting some water onto the paper. And again, after the second or third time, it just basically holds it together because it's a wet paper on wet paper, but it's not the glue which holds it together anymore. The next one is the rough surface, so I use the wing boot again. $29. So the next test is to test it on skin. After 7 times it fall off. And then our last one would be on the t-shirt. After 24 times that fall off too. So what we can do now, we can put our like observation on a little graph so it's easier to see what we found. So if you do like a 2-axis, which you have on the one axis is the number of the trials, how often you try to post it on the other one is your surface. And then you can sort it from like very smooth, like your smooth surface, to I guess the next one would be the t-shirt, then the rough surface of your boots, your skin, the water surface, and then the sandy surface. And then add how much your post-it and your self-made post-it was holding up. So you get for the smooth, I got 100 or more than 100 actually. For the t-shirt I got 100 for the post-it. For the rough one I got 100. For the skin I got 37. That was very tiny, and the sandy didn't hold up at all. So then I put so that would look something like that. So we have 3 surfaces which hold it really well for the post-its, and then not so well on the other 2. And if I put the temporary sticky note on it, so on this smooth one I have 32 around here. On the t-shirt, 24 around here. Rough one 29 would be a little bit more. Skin 6. Not the same. That would look like that. So what we easily can see from this graph is that the homemade post-its doesn't work as well as the post-its you can buy, which is not so surprising. And that the post-its which you can buy work really well on surfaces which don't have anything else on it, but as soon as you put them on a surface which either with oil on it, like your skin, or with water or sand on it, they don't work as well anymore. And so one reason the glue you have in these post-its is a little bit a different kind of glue. It's still polymers, like the glue we talked before, but this time these polymers are sorted in like little, kind of like little circular shapes. It almost looks like a basketball if you zoom in on these things. And if you press on them, these are called pressure sensitive adhesives, so if you press on them, these polymers basically spread out on the surface. And if you take them off, they basically shrink back into this ball size. And it all depends on like how well they can do this. It's like spreading out and coming back to the post-it, so it sticks on the post-it. The glue we discussed before, like your regular paper glue, don't have polymers which that kind of behavior. They have just the regular glue polymers, so they basically spread out once and then they're on the other surface. You put it on, and you saw this, if you put this on the paper, it gets harder and harder when the glue dries, and at some point you don't have any more glue on your post-it left, so that's why it can't stick for that long. The reason why it doesn't work so well on surfaces where there's already something on it, the oil or the water basically disrupts this like flowing out of the polymers and shrinking back onto the post-it. So I hope you had fun with the Sticking with Chemistry from the ACS booklet, with the 2 experiments we did today. I encourage you to read through the booklet. There's a lot of good information in there and good of stories. There's also a 3rd experiment in there which is called testing the tape stickiness. So for that one you would need any kind of different type of tapes and some marbles to run over and see how long they can roll on the tape basically before they kind of like stick on that tape. And that's it for today. All the materials you got, you can dispose them either in the trash or the sink. These are all household materials you probably would have had at home. Have fun with more chemistry next week. Bye.